So in this tutorial, so we will see gear and lobe pump, the theoretical and the tutorial. So this is problem number 1. There is an external gear pump. Assume it is a module gear with a teeth number Z equal 13. The diameter of the addendum circle, which is a D node here. So we have a addendum circle is actually the center point until this level. It's equal to 75 millimeter. The distance between center point A is 65 centimeter. So and the gear width B is 35 centimeter. So mean the distance here is 35 centimeter. The volumetric efficiency eta is 90% and the rotating speed N is 1500 RPM. Calculate the flow rate of the pump. See, normally for gear pump and lobe pump, so we are not calculating the efficiency. We don't have some kind of manometric efficiency or hydraulic efficiency, because normally in gear pump and lobe pump here, the main purpose of this pump is actually to transferring one point to another point. So and the location, the level of that point is not too high, because the capability of gear pump and lobe pump is not to elevate, not to push the liquid up to the certain elevation. So and then the idea of gear pump and lobe pump here is actually they will transfer using the idea of volume. So means that actually we need to calculate what is the volume of liquid that will trap into this gear. So this is the main idea. However, in gear pump, sometimes we have difficulties because we cannot calculate the volume straight forward by using a normal equation. So here I would like to introduce you how to calculate how to predict or how to estimate the volume of the gear pump like this one. So and then the idea of dedendum and addendum here, I think you already know this one, because I think all the mechanical engineers know how to draw a gear in your design class. You have learned SolidWorks or AutoCAD and so on. For sure you learn about this in mechanic design or whatever. So according to my experience, I have learned this how to design the gear here. Okay, so this is just the reference for you. So I hope you could understand all the design of this gear here. So and then actually the idea here, the velocity, the volume actually will trap into this space. So and then when the gear push into this area, so it actually squeeze the fluid into the to the other component. So that's why the basic idea is we transfer the volume by pressing the liquid here and move it to another volume, to another area. So this is the design of the gear tooth. So we have the addendum and dedendum. So I hope you could understand here. So the simple one is this is the dedendum. So means that here the design is still straight like this, and start the addendum here. So it start to have a curve one like this. So the design, the purpose of this design is to make sure that when these two teeth meet each other, so there are no wear and tear in this point, because this point is designed correctly. So this is the idea of the gear pump. So means that we have an inlet here. So and then it starts the vacuum created here as this unmeshed oil enters from reservoir. So and then point number 2 here, so oil is carried out like this one, so mean this is the volume that we need to calculate. So, and then here again at point number 3 here, uh, it is forced out of pressure port as this go back into mesh. So and then because at this area the liquid is pressed by the teeth, so it could go at outlet here. So this is the mechanism of the gear pump. So and then normally for gear pump we will use totally the same gear for left and right side. So and then we will have some kind of this definition. So we have this capital D here is the gear external diameter, like this one. We have the small d as gear root diameter, so as this one. We have a W, the bore width from here to here. So and then we have the center distance, the C, as shown here, the C, and we have the GW, the gear width, because we are going to calculate the volume. So we need to know the diameter and we also need to know the width of the gear. So because the design is actually not a common design, so I propose I will show you two common equations to calculate the volume for the gear pump. So the equation number 1 is like this. So we could calculate the volume by multiplying pi over 4 with d square minus d square times the gear width. So another equation that you could use to solve the gear pump here by using this equation. So means that the volume is equal to pi over 2 d square over c square times gear width. So however, the first equation may be the most common equation. So and then because we know that the addendum circle diameter is 75 millimeter here, and number of teeth is 13. So in gear pump, both gear are the same. Center distance between two gears is equal to pitch circle. So now the A here is is equal to 65 millimeters. So and then the module, so this is quite a very specific, because if you draw a teeth, if you draw a gear, actually you need to know what kind of gear that you want to calculate. So and then it's depend on the module. So let's say this is the common one. So we could calculate the M is equal the pitch equal to number of teeth. So means that it is equal 65 divided by 13. So we have 5 millimeter module. So I hope you could make some revision how to design a gear, or sometimes you could you need to read. If you have a plan, you have a drawing, so if we have a gear there, normally we will write what type of module for that gear. So and then the M is equal to 5 mm. In general, for module gear, addendum is equal to the module value, so we could have this idea. So and then we could calculate the idea of this one. The addendum is actually the addendum plus clearance. So we have 1.157 times M. So we have 5.785 millimeter. And the total depth will become addendum plus addendum, 5 plus 5.785. So it is equal 10.785 millimeter. So from that calculation, we could know that the diameter of the addendum circle is 75 minus 2 times 10.785, so it is equal 53.43 millimeters. So here it's quite complicated, but actually if you are working on this gear pump, so the best way is you could get the diagram of that gear pump, and then you start to get all information about this diagram. So you need to know what is the value of W, small d, capital D, C, and the width. Then you could use the equation of this one easily. So the calculation here is actually to show you sometimes you could do the calculation based on the type of teeth, because as I said, in drawing sometimes people will give information about the type of the gear that in the drawing. Okay, let's say we use the first equation here. So this is the equation. We substitute the value, so we will get the volume flow rate is equal to okay, so this is the volume, the equation for the volume, and then to calculate the volume of flow rate, we multiply with the RPM here. So because the RPM is rotation per minute, then we need to divide by 60 because we need to get units here with second. So we multiply with 1500 over 60. So we will get the volume flow rate here is equal to 1.904 liter per second. So if the volumetric efficiency is 90%, so means that there is some losses, or the gear rate, the gear pump cannot transfer 100% of the theoretical volume. It's only could transfer 90% from the theoretical volume. So means that we multiply the volume flow rate here with 0.9, so we could get the volume flow rate in actual calculation as 1.7136 liter per second. So and then we could calculate the, we could compare with the second calculation. So this is the second equation. We substitute all the value. We multiply with the RPM over 60, 1500 over 60. So we get this value. So we could get the actual flow rate here is equal to 1.7316 liter per second. If you compare the answer, so we still have here the first equation, we have 17136, and this is the second equation, 17316. So the error or the difference is not too much. So means that, however, it is good for you to calculate the gear pump using the first equation. Okay, for problem number 2, I would like to introduce with you about a lobe pump. So a lobe pump running at 300 RPM is pumping soybean oil through a 3.0 centimeter diameter pipe. The pump is driven by a motor that is using 285 watts. Assuming an overall pump and a motor efficiency of 65%, what is the pumping rate if the suction and discharge pressure are minus 35 and 160 kilopascal respectively? So first, we could calculate the power here. So power here is actually written as rho GQH. So rho GQH, if you see the equation, we could rearrange to become rho GH and Q. So rho GH and Q here is actually the delta P, the difference of pressure. So according to this question, we could calculate the difference of pressure by deducting the outlet and inlet pressure. So we have 160 minus negative 35 kilopascal, and then we could multiply with the flow rate. So we could get it is equal 195,000 Q. So and then we know that the efficiency is 0.65. So we could calculate that the power. So efficiency means power out divided by power in. So power in here means the power that we supply to the pump. So from the question, we know that we need to supply around 285 watts. So it is become the power in. So and then according to this equation, we could calculate the Q, which is equal to 0.95 liter per second. So this is problem number 3. A 2 lobes rotary positive displacement pump moves 0.6 centimeter cube of motor oil in each lobe volume. For every 90 degree of rotation of the shaft, 1 lobe volume is pumped. If the rotation rate is 550 rpm, calculate the volume flow rate. So this is the example, the diagram of the lobe pump. So what you need to understand by for every 90 degree of rotation. So I hope you could understand here. So one rotation means this lobe from the horizontal will become vertical like this. So if this lobe is vertical, so means that this if it's if this lobe is rotate counterclockwise like this one, so means that it will turn this lobe into horizontal, and it's rotate clockwise like this. So means that every changes is actually 90 degree. So this is the idea of this statement. So and then I think you already know about this. So for each lobe volume, so each lobe volume means the volume inside this one. So mean every time it's turned 90 degree, so it is 0.6 centimeter cube of motor oil being pumped. So we could calculate this one by this calculation. So for every 90 degree of rotation of the shaft, 1 lobe volume is pumped. For one complete rotation, there is 4 lobe volume has to be transferred. So means that the closed system of that one, so or the total volume can be calculated as 4 times 1 volume of lobe. So means it is equal to 2.4 centimeter cube. So and then to calculate the flow rate is the total volume here divided by rotation here and times with the lobe speed. So in this situation, the rotation here is equal to 1 because we use the volume of the total rotation. So rotation means the from one lobe here. So one lobe here to rotate from this point to its original location. So it is 360 degree. So and then we could calculate the Q here is 2.4 divided by 1, mean 1 full rotation, times 550 rpm. So it will contribute 1320 centimeter cube per minute. So and then this is the question number 4. We have a problem of this one. A 3 lobes rotary positive displacement pump moves 0.6 centimeter cube of motor oil in each lobe volume. For every 60 degree of rotation of the shaft, 1 lobe volume is pumped. If the rotation rate is 550 rpm, calculate the volume flow rate. So what I need to what I hope you could understand here is about the for every 60 degree of rotation of the shaft. So here we have a situation like this one. So it is a 3 lobes, okay. So and then 360 divided by 3. So the angle here is 120. So and then what you need to understand here, if the lobe here is moving counterclockwise like this one, so means that from this area to this area, so actually it also change this one to this area, okay, because it's moved like this one. However, if you see the rotational is actually it's become only 60 degree. So means that there is only 60 degree move for one rotation. So I hope you could understand this one, because sometimes students are confused with the angle of this angle of this lobe. So and then we could calculate this one. So we calculate the total volume. So we have a 60-degree here. So the total volume is 360. So we multiply with 6. So we get it is 3.6 centimeter cube. So and then we could calculate the total flow rate by having this one, 3.6 times 550. So we will have 1980 centimeter cube per minute. So here the unit is per minute because the lobe speed is maintained 550 RPM.